find y prime if sine of x plus y equals y squared cosine of x. All right, again, we have an equation with x and y, and it's difficult, if not impossible, to write this as y as a function of x. So we're going to have to use implicit differentiation, which means we need to differentiate both sides with respect to x. So we have d over dx of sine of x plus y equals d over dx of y squared cosine of x. And let's just go through from left to right. All right, on the left-hand side, we have sine of x plus y. We need to use the chain rule here because this is a composition. The outer function is sine of u. The derivative of sine is cosine. So we're going to have cosine of x plus y times the derivative of the inner function. The derivative of x with respect to x is just 1, plus the derivative of y with respect to x is dy over dx, or we can also just write y prime. I'm going to use this as an opportunity to switch from dy over dx to y prime, specifically because we're asked to find y prime here. So this is as good a time as ever to use y prime notation. And it's a little less writing, which is nice. So that's what we get on the left-hand side. On the right-hand side, we have to use the product rule because we have a product of two different functions here. So the product rule says we take the derivative of the first times the second. Now the derivative of y squared is 2y, but y is a function of x, and we're differentiating with respect to x. So using the chain rule, we have to multiply by the derivative of y, which is y prime. So that's the derivative of the first factor times the second, cosine of x, plus the derivative of the second. The derivative of cosine of x is negative sine of x, times the first, which is y squared. So now we have done implicit differentiation, but we want to know what the derivative is, y prime, so we need to get y prime alone. And the way that we do that is get all of the terms with y prime on one side and all of the terms without it on the other. So on the left, we're going to have to distribute this cosine to the two terms in parentheses so that we can split the term with the y prime from the one without. Cosine x plus y times 1 is just cosine x plus y. And then plus cosine x plus y times y prime is just that. And then on the right, we've got 2y, y prime cosine x. And then I'm going to write this just as minus sine of x times y squared. Now we want to get all of the terms with y prime on one side and all of the rest on the other. So we can choose to do this either way. Let's get the y primes on the left. So we're going to have to take this term on the right and subtract it to move the y prime to the left. And we're going to have to take this cosine on the left and subtract it to move it to the right. So when we do both of those, this cosine of x plus y times y prime is going to stay on the left. And then this other term is going to move to the left and become negative because we're subtracting it. So minus 2y, y prime cosine of x. And then on the right, we still have this negative sine of x times y squared. But then we're also going to have negative cosine of x plus y, because this term that doesn't have a y prime, we're going to subtract. So it's going to become minus cosine of x plus y on the right. Now, to isolate y prime, we need to factor out the y prime from the terms on the left. So that's going to be y prime times cosine of x plus y minus 2y cosine of x. And that equals negative sine of x times y squared minus cosine of x plus y. And then to get the y prime alone, we divide both sides by the whole thing in parentheses. And so that's going to give us the y prime on its own. And then on the right-hand side, we're going to have negative sine of x times y squared minus cosine of x plus y all over cosine of x plus y minus 2y cosine of x. And this is a perfectly good final answer, but it's also possible to have the same thing, but with all the signs reversed. If instead of trying to get all the y primes on the left, we had moved them to the right, all of those terms would have opposite signs. And so an equivalent answer is going to be sine of x times y squared plus cosine of x plus y all over negative cosine of x plus y plus 2y cosine of x. And of course, we could switch the order of any of the terms in the numerator or denominator. We don't need to write it both ways. I just wanted to show both of these because it's possible that some students instead moved the y prime to the right because they wanted to have fewer terms with negative signs. So I just want everyone to understand that this is also an equivalent answer. There's often multiple ways that we can write these answers. So if you disagree with someone else's answer, take a moment just to make sure that you're not looking at two equivalent versions of the same answer.